Right, good morning everybody. So today we're going to be doing velocity time graphs, and to do that I'm going to need a ruler. No, that's a protractor. Now this is a ruler. Okay, so a couple of things that we've got to note here. If we wanted to find the acceleration, that's when something's speeding up, or deceleration, that's when something's slowing down, we've got to take a tangent to the graph. I'm going to show you that on the main board in a minute. If we wanted to find the distance of a velocity time graph, we've got to cut the graph into strips and find the area of those strips underneath the graph. So, over to the main board now. We're going to have a little look here at finding the acceleration of this graph at time t is 7.5 seconds. So I'm going to put my dot on 7.5 seconds, halfway between the 5 and the 10, and then I'm going to take a tangent. Now tangent, very important, we mustn't cut the curve when we're doing the tangent, but what we can do is just going to touch that curve there, and I'm going to do a line here. Now this is a successful tangent to the graph. I'm going to measure across. Now I've chosen this deliberately, I've cheated a little bit because I've made this horizontal piece exactly 10. I'll show you why in a minute. And the vertical bit, I've got 9 here, then I've got 18 here, which gives me a total distance of 9 between the 2 points on the vertical shift. Now, the acceleration is going to be the gradient of this tangent. So the gradient is going to be the vertical movement, which is 9, divided by my horizontal, which is 10. You can see why I chose 10 now. And that gives me 0.9 meters per second squared, because we're dealing with acceleration. So acceleration is 0.9 meters per second squared. Okay, that's that bit out of the way. Supposing now I wanted to find the area, the distance under the velocity time graph, what I need to do now is to cut into strips and find the area. So here's where the ruler comes in again. I'm going to cut this into 4 strips. That's 3 lines makes 4 strips. I'm going to label them A, B, C and D, and out of each strip I'm going to make trapeziums and triangles. So here's the graph there, cut into strips. Okay, over to this board now. We can now work out the area of all of the strips. So, if I was to consider strip A, which is a triangle, it will be half times the base of the triangle, which is 5, times its height, which is 10, and that would then give me an answer of 25. And I was to work out the area of the second strip, it's a trapezium, it'd be half lots of 5 plus 16, multiplied by 5, which would give me an answer of 52.5. Then, if I wanted to work out the area of the third strip, which is also trapezium, half the 16 plus 13 multiplied by 5, remember the 2 parallel sides there, that will give me an answer of 72.5. And then finally, if I wanted to work out the area of D, which is a triangle again, that would then be 52.5. To find out the total distance travelled, I've got to find out the total area of these strips here. So I've got 2 lots of 52.5. No, I haven't. I've spotted a deliberate mistake. That now becomes 32.5, because half of 65 is 32.5. So, to find out the total area then, I've got to add these numbers together, and that would then give me a grand total of 182.5 meters. So, apart from the small mistake there, the area between the 2 traffic lights which we're dealing with gives a distance of 182.5 meters. And that is how we do velocity time graphs relating to finding the distance and also the acceleration. Go back to there to have a summary of what we need to do to find the 2 various methods.